y0 minus 1/2 gt squared. That gives us the time of fall, square root 2y0 over g. Let's do a problem. A ball rolls off a table with a horizontal velocity of 2 meters per second. Means that is the horizontal v sub x, and falls 1.3 meter away from the foot of the table. What is the height of the table? So the question we have here is that you have a table. If that is the table, a ball rolls off that table. If I roll this ball and look at that, it rolls off the table and the ball goes and falls at a distance x equal to 1.3 meter away from the foot of the table. Well, you can see, because we know the horizontal velocity and the horizontal distance, you see, we can calculate the time taken for the fall. Is that right? All right, let's draw that. Now this is the ground, and here is the table, and the ball is projected with a horizontal velocity Vx equal to 2 meters per second. And how is the ball going to go? It falls in a path like this. There you are. And the horizontal distance traveled is x equal to 1.3 meter. Now we are looking for y0, the height from where the ball was dropped, the height of the table. Well, you can see the ball projected there, is that right? Look at that one more time. There you are. Now, we find the time of fall t using what equation? Give me an equation for x. X equal to Vx multiplied by time, isn't it? X equal to Vx multiplied by time. Therefore, 1.3 equal to 2t, or t equal to 0.65 seconds. You see, we use the horizontal distance traveled by the projected ball to calculate the time taken by it to fall to the ground. And during this time, it traveled a vertical distance y0. So what is the equation for y0? y0 equal to 1/2 gt squared. Well, to be strictly, this is our equation. Our equation is y of t equal to y0 plus vy0 minus 1/2 gt squared. This is our y position equation. And we now know that during this time, this y will become 0. And vy0 is 0. You understand that? During this time, 0.65 seconds, you see the ball falls to the ground in that time, then y will be 0. And of course the initial y velocity is 0. So I could write 0 equal to y0 minus 1/2 gt squared. And rearranging this gives you y0 equal to 1/2 gt squared. We know the value of g, we know the value of t. Therefore, y0 is 2.07 meter. The height of the table is 2.07 meter. You can see this can be applied in any situation of similar type. Okay, let's do another problem. An airplane traveling at 80 meters per second at an angle of elevation of 250 meters drops a box of supplies to skiers stranded in a snowstorm. at what horizontal distance from the skiers should the supplies be dropped? Now, I hope you understand this concept. Now, suppose this is the airplane traveling, and from the traveling plane you're going to drop a box. Now, that means this box has the same horizontal velocity of the plane. So when the plane drops this ball, will it simply move vertically down? No. This box, well, assuming this is a box, I can't find a box, so I'm using that as my box. Well, suppose this is the box that the airplane drops. Now, just before it is dropped, you can see the box is moving with the velocity of the plane. So this has a horizontal velocity. What is the horizontal velocity of the box? Is the velocity of the plane. So the box is dropped with a horizontal velocity of 80 meters per second. It is a horizontal projectile. All right. Now what we need to find is the pilot has to figure out, you see, because the box will travel a certain horizontal distance. If those poor people are stranded, say somewhere there, the pilot needs to release the box much before he reaches directly above those stranded people. Then only the box will travel and fall where those people are stranded. So he's got to figure out how much will be the horizontal distance this box will travel. So our aim is to find the horizontal distance traveled by that box. Okay? All right. Vx initial, the velocity, the horizontal velocity of projection is 80 meters per second. And y0 is the height from where it is projected is 250 meters. Now here's the box that is dropped. Its horizontal velocity is 80 meters per second. And it is dropped from a height of 250 meters. We are looking for x, this distance. That is, there the box coming and falling on the floor. Now look at the motion of that box again. It has an initial horizontal velocity. So this is how the box is going to fall. Now we need to find this x, and you know x equal to Vx multiplied by the time of fall. We know Vx. Therefore, we need to find the time. Well, it is very simple. Since we know y0, we can find the time of fall. What is the equation for the time of fall? T equal to square root of 2y0 over g. Is that right? Yes. So we use the values of y0 and g, and the time of fall is 7 seconds. And during this 7 seconds, it is traveling horizontally with a velocity 80 meters per second. So what is going to be the horizontal distance the box will move? The horizontal displacement of the box will be x equal to Vx multiplied by that time. That will be 80 meters per second times 7 seconds. That is 560 meters. Okay, let's look at another problem. Well, there is another part for it. Find the velocity of the box as it reaches the ground. Well, you see, when the box reaches the ground, suppose my hand, this hand is the ground. The box comes and hits the ground. Look at that. When the box hits the ground, it has a horizontal velocity. What is the horizontal velocity? 80 meters per second. And in falling through a height, it has also acquired a vertical velocity. That means it has a horizontal velocity and a vertical velocity. Alright, let's find these velocities. Its horizontal velocity is Vx equal to 80 meter per second. And we will find the vertical velocity using this equation. Vy equal to Vy0 minus gt. Now, what is Vy0? What is the initial vertical velocity of the dropped box? It is 0. Therefore, Vy equal to negative gt, negative 9.8 times 7. We calculated the time taken by the box to fall. So that is negative 68.6 meter per second. So that means the box, when it falls to the ground, the instant when it falls to the ground. I know most of you would say, but don't the box come to a rest? Yes, it will. You see, the instant when it touches the ground, it has a horizontal velocity and a vertical velocity, which is this. Alright, so the vertical velocity is negative 68.6 meter per second. Therefore, the resultant velocity will be this vector, and we are supposed to find that vector. This is what we need to find. And what is the magnitude of this vector? The magnitude is square root of Vx squared plus Vy squared. So Vf, the final velocity when it touches the ground, will be square root of Vx squared plus Vy squared. That will be square root of 80 squared plus 68.6 squared. That is 105.4 meter per second. In other words, that box will hit the ground with a speed of 105.4 meter per second. And if it is not packed well, it is likely that the box will shatter into pieces. Well, and what is the direction? We need to find this angle. You notice that the x is positive, y is negative, therefore the angle is a fourth quadrant angle. Is that right? So the angle theta is such that tan theta equal to y over x, Vy divided by Vx. And therefore theta is tan inverse of what? Negative 68.6 divided by 80, and that is negative 40.6 degrees. You see, the angle is a negative angle. It is a fourth quadrant angle. So we now found the magnitude of the velocity and its direction. A very important type of problem. Let's now do another problem. A person standing on a cliff throws a stone with a horizontal velocity of 15 meter per second, and the stone hits the ground 47 meter from the base of the cliff. How high is the cliff? We are looking for y0. We know the time of we know the horizontal distance traveled